I've been building data platforms, data products for more than 10 years and been in this lakehouse space for a long time. So when you see these two images up on the screen, the left and the right-hand side, what is the first emotion? Which one do you resonate with the most? The one crying in the corner or the one with the Zen? I see a couple fingers pointing to the other side, right? Why is this the case? Why is it the case that you're ready to go to the lake, you put on your swimsuits, and you end up laying on the floor crying, right? Well, data lakes are a messy range of just files scattered everywhere. It's up to you, right? In contrast to a proper database system, there are no native services or systems that help you organize, catalog, sort, index, cache, or provide any meaningful management of your files in general. And so you're left to your own devices. And if you're very good at being organized, maybe your data will be pretty organized. But if you're not, and if you're like me, that's kind of how my home office looks like at home, but no one else can see since they see the camera pointing at the back wall, right? So over the last 7 to 8 years, at this point now, there's been a lot of work across the community to address many of these shortcomings of data lakes themselves. And open source projects like Delta Lake, Apache Hudi, Apache Iceberg, are considered 3 of the leading table formats at this point of what is now called the data lakehouse. And data lakehouse projects, these at their core, if anyone here is unfamiliar with these projects, are basically they add metadata layers on top of your raw files to bring foundational characteristics to your database or data warehouse, including things like transaction support, including things like schema enforcement and governance, allowing you to bring BI directly to the data lakes. The core of this is to also have your data stored in open formats so you can truly decouple storage from compute and bring best of breed tools to your data lakes for all of your use cases. So how did it all get started? Let's talk a little bit about the origin stories of these projects, where they came from. I think it's interesting to look at these origin stories because these different roots, I see they still have influence on how some of the communities are driven today. And I think there's interesting insights. So Hudi, Apache Hudi was open source from Uber in 2017. It was created in 2016, open source in 2017. And Uber at the time, they were struggling to build a petabyte scale, near real-time platform to process all their trip data, run fraud detection, a few other use cases like this. And so Hudi had a focus from the beginning on incremental streaming style workloads. Apache Iceberg was open sourced in 2018 from Netflix, where they were struggling with S3 scale limitations in the cloud for batch workloads, and they wanted to also replace the Hive table format and bring a new portable metadata layer on top. Delta Lake, I was their product lead for Azure Databricks at the time when we first created Delta Lake, and then open sourced it in 2019. And some of the initial goals there were to replace data warehouses and replace data warehouse functionality and bring that functionality to Apache Spark and make Apache Spark the best in industry processing engine. So now the most common narrative I hear when you look at these 3 table formats is, hey, they're so similar in nature and it's just a matter of time until the 3 of these projects converge and we will all have just one table format. In my opinion, my personal opinion, go read the roadmaps, go attend the community meetups, go read the PRs, the discussions in GitHub. I think you'll find, it's very apparent once you do so, that each of these projects are purpose-built by diverse open source communities for specialized needs, and they actually have different goals and objectives of what they're building towards. Delta Lake is building to further success for Spark. Iceberg is building to create a portable format layer and catalog replacement. Apache Hudi is building comprehensive database services on top of the lake. So, I also forgot to mention, there's more than just these 3 table formats. Actually, I know of at least 6. If not, there's a couple more that are trying to claim they're more. There's one that's growing right now and getting a lot of traction. It just voted to graduate from the Apache Software Incubation Program, Apache Pymon. How many people have heard of Apache Pymon? Oh, nice. We got a couple. Oh, nice. Have you guys used Pymon? No, okay, interesting. Yeah, I just learned more about the origin story recently for Apache Pymon as well, and it was some Iceberg committers that were struggling to scale some real-time workloads with Flink, and so Apache Pymon, it's more native around Flink and streaming use cases there, but it's gaining a lot of traction just graduating the Apache incubator, so congrats to Pymon as well. But let's double click into these table formats and how are they operating, what does it look like under the hood for how they're laid out. They all offer metadata abstractions on files in cloud storage. And these metadata files are designed slightly differently, but the overall idea is kind of the same. So if you look at them, what's my order on the slide? I've got Delta on the left. Yeah, it's still your left as well. So Delta Lake on the left, they have a JSON-based transaction log. And as you write commits, it updates that transaction log entry so that when queries come, it knows which files are relevant and where to point the query operations. Apache Iceberg has what they call manifest files. And these manifest files, basically also, they have like a list of entries that tell you which files are relevant as well. Apache Hudi, they build a more timeline-based style of metadata. And all of these metadata layers that are built on top, there's several purposes. You can kind of condense it down into maybe two main goals, perhaps. One of those is to enable ACID transactional guarantees on object storage or cloud storage, which is otherwise immutable in nature and very difficult to apply updates, apply deletes, these kind of things to those objects. And especially when you're getting closer to low latency or concurrency of writers, multiple writers happening at the same time. So these metadata files also, for all three of the projects, will build advanced statistics and ways that when query engines go to ask for data and retrieve data, the metadata assists the query engine to skip partitions, to skip files, and to zoom into and very quickly retrieve the data. So you can get amazing performance speedups over if you're just using flat Parquet files or things like that. What does it look like at a higher level when you're actually looking at your storage, whether it's on your local device or in something like S3? You're going to see a folder, and inside that folder, this is where you have the metadata and the data side by side. So there's the Hudi timeline, there's the Delta Lake transaction log, and the Iceberg manifest files, okay? These are all on top of Parquet files here. Now, since I've researched and written extensively on this topic over the last few years, and I've also personally helped hundreds of organizations adopt these technologies, the most common question that people will come to me and ask is, hey, which format should I choose? And not only is that an incredibly complicated answer to give, it's nuanced and it very much depends on your use case. So it's not something you can just answer off the fly. It involves it in a deeper discussion. But while I thoroughly enjoy discussing the differences of these projects, today I'm really more excited to talk about something that I think is far more important. Looks like it doesn't show on the slide. Oh, there it goes. What if you could use all three? Now, when I asked this question, and this I haven't been asking for very long, but just recently, we'll get to it in the presentation here, but what if you could use all three? The most common response, I hear one of two things. I hear either shrieks of joy and relief, or I hear, hey, I haven't thought about this before, why? Why would I want to? Why would I consider wanting to use more than just one? And so I tried to put together a couple of examples. This is by no means comprehensive, but I just wanted to show a couple examples of how you might possibly benefit from having a mix and match of scenarios. So let's take if you are writing the data on the left-hand side. Looks like my formatting got a little bit mixed up here. But say for example, you pick Apache Hudi with something like Spark on EMR. You can get the fastest writes for mutable workloads and really flexible tuning parameters for ingestion type workloads. But then you can pair it with, for example, Delta Lake with Databricks and have native photon acceleration for the fastest queries on the read side. Or you need to read it in Snowflake, and actually Snowflake only supports one of these. And so you have to have it as Iceberg as well. Or you're using Delta Lake with Fabric in the Microsoft Azure ecosystem. But then you want really fast, like record level indexes or secondary indexing for like point lookups or these kind of things. Then you can use Apache Hudi on the read side as well. So you can mix and match to get some of these. I just want to share a couple of these examples. So now, with this being said, what I'm super excited to share with all of you here in the community today, there is a brand new open source project that recently launched and just now has been donated to the Apache Software Foundation, incubating in the Apache Software Foundation, called Apache Xtable. So you can go to the website xtable.apache.org, find the repo right here, and you can dive into it. So unrelated to current events, the X in Xtable has nothing to do with Elon Musk, and it has more to do with cross-table interoperability across these three table formats. And any future table formats that we see rise in popularity over the next few years. So Apache Pymon's already looking at this as well. A little bit of timeline for those that are seeing this for the first time. So myself, I work at OneHouse. And at OneHouse, we announced this idea that we were building in February of last year. And very quickly, we got a lot of excitement and traction. And we co-launched the original open source version of this project in November of last year. We co-launched it with Microsoft and Google. And it was called OneTable at the time. So if you heard the name OneTable, it's now officially renamed as Apache Xtable, as we donated to the Apache Software Foundation. And now at this time, there are a lot of great partners and committers, contributors, mentors alongside us in the project that are building there in the community as well. So let's talk just a little bit about how does it work. That's probably the most burning question that all of you have here today as well. Basically, how it works is Apache Xtable, it does not touch or read or rewrite actual data or actual Parquet files. Apache Xtable will read metadata and translate it and write other metadata. And it does not have its own representation of metadata, its own specification, its own format, nothing of that. It's just an interoperability translation mechanism. So what you see on the left-hand side, say, for example, you were using Apache Hudi like I showed you before, you have a Hudi metadata folder. This is a representation of a timeline and Parquet files. When you execute Xtable, it will look at that timeline, which relative to your data sizes, the metadata is very small. It will look at that timeline and it will know how to interpret and write out the metadata for Delta Lake and Apache Iceberg, generate those manifest files, generate that transaction log. And now when you execute a query, say you're using Spark, spark.read.format, you can plug in Hudi, Delta, Iceberg, and read it as that native format. So another reason why I find this movement for interoperability very exciting and urgent for the community is noticing the trend of companies that are building multi-engine data platforms, mixing and matching some of the best technologies for their use cases. And as data products and services become more elastic and more serverless, it's very easy to combine and use these kind of workloads. And these statistics on the screen from SiliconANGLE, the folks over at ETR Research as well, they're showing that between 40-50% of people that use Databricks are also using Snowflake. And there is, of course, Databricks has Delta Lake. Snowflake announced support for Iceberg just recently as well. So Databricks also sees this need firsthand to invest in interoperability. And alongside Xtable, they're also investing in interoperability with their Delta Lake Uniform project as well. So now I'm very curious to hear from the room here as well, which query engines are you using? So I created this little survey. You can scan it with your QR code, hit a vote, and if we can switch the screen to show my laptop, then I'll show the results live. It's just some anonymous survey here. Just curious to see the diversity of the mix-up at Data Council. Let's see what we vote up here. Lots of BigQuery, nice. BigQuery. Query, Spark, Snowflake's growing. Okay, Spark's in the lead now at this point. Where's my Flink people at? Yeah, fist pumps. There we go. Get some more Flink in there. Okay, we got some Trino, Presto. Awesome. Yeah, thanks for sharing. I think you can see it's obvious even just from this really fast, fun survey here. There's a good mix of diversity in this room, and of course this applies across the whole industry as you meet with your peers, and even as you change jobs or things like that, you get exposed to new tools, new tech, new products and services like this. If we could switch back to the slides. This was one of the core motivations for why we created Xtable in the first place, or created OneTable, and then donated to the ASF as Xtable. So because our company and our product, we're building a foundation for the data lakehouse, and building services like continuous data ingestion. We'll run data optimization on all three of these formats, so all the fine-tuning of that metadata, whether it's clustering, compaction, indexing, cleaning. We run all these things that you take for granted that are in databases, and we run this all on your Apache Hudi, Delta Lake, or Apache Iceberg tables, and we can build low-code pipelines. The goal is to decouple your data and your data infrastructure from query engines fundamentally, and allow you to pick and choose and integrate what you would like. So that was some of our main motivation. I think you can see that's clear as well from the room here on the survey. We got about 60 respondents on that. So that's really great. Let's look at a demo and see this live in action. If we could switch to my laptop here on the podium, I'll walk you through what this looks like in real life. Okay, great. Okay, what I have here on the screen, this is a Jupyter notebook that is all the queries and things that I'm running here are backed by an EMR Spark cluster on AWS, okay? And I'm gonna walk you through an example of using Xtable in three different ways, okay? The first is very simple. I'm going to read a basic Parquet file, and if I were to show you this on S3, it's just like one Parquet file, so I'm not talking about a specific data story or volume or scale or anything here, but I have some data. I have some table, right, in this Parquet file. I'm first going to write this Parquet file as an Apache Hudi table on S3. So as this writes, then I will be able to see it show up in S3 here. If we go to the Lakehouse folder, this is my path here, Lakehouse, my table. If I just a little smaller, we might be able to see both. Yeah, I could zoom in a little bit. Thank you for calling that out. How about this? Does that look better in the back? You good? Okay, perfect, thank you. All right, so I wrote the Apache Hudi table. If I look in here, my Xtable. All right, I've got that Hudi timeline, and I've got the Parquet file, right? Okay, now if I were to come here and I can just prove it back to you that, hey, I can actually read this as an Apache Hudi table. It's a valid Hudi table here. Now, of course, if I attempt to read this as an Apache Iceberg table, it fails. This isn't an Iceberg table, this is a Hudi table, okay? So normally these wouldn't play nice. And but now with Apache Xtable, I mentioned there's that config.yaml file. So if I switch over to my local here, we can even look at that config YAML file. Maybe I need to zoom this in for you as well. Is that good? All right. So, and I specify my source format is Apache Hudi, and I would like to translate the metadata to both Delta Lake and Iceberg, and I tell it the location where my table is at and what my table name is. Once I have that in place, then I've already compiled. You can find in the Apache Xtable documentation. So if you're at the website, there's links to docs here. And in the quick start, you'll find this here, how to run these executables, but also how to compile that jar file that I'm using here as well. So I can take that jar file, and let me just quit here, and I will run the translation of the metadata. Let me show you what this is going to look like in S3. So this is my same table here. I can refresh it as we go. Let's see, like, as it's building. So it's still working in the background. Okay, so I've got the Delta Lake transaction log building right now. I've got the Iceberg manifest files building right now. And the first execution takes a little bit longer. The subsequent executions all run in an incremental fashion. So it's a very lightweight operation when you run it inside your workload. And as this builds, now I have, I bet if I crack open one of these, I'll see it. Yeah, here's the Delta Lake transaction log and the Iceberg manifest files, okay? So now if I come back to my notebook here, hey, let our powers combine. We got the three all loaded together. Now if I try to read this table, I can read it directly, the same table with the .format Iceberg. And that very same table, I can read it as .format Delta. Okay, so it's magic. Now I've got, I started with just one. There's no way that these worlds would mix and match in the past. And now I can have all three. I can have all three simultaneously. Another question that sometimes people ask me is like, oh, how can I like operationalize this in a production workload? And we have several customers today that are using this in production workloads today, powering their line of business applications on critical services. And there's a couple methods, right? You saw that it's like a standalone execution that I can just run and operate on my own. This means it's portable for you to deploy in a couple fashions. Some ideas that I've heard discussed out there, you could perhaps set up like an SNS SQS listener that finds when any of the metadata is updated or new data has arrived in the table, and that can trigger an event to run that executable. Or you could take that jar file and trigger it from a Lambda function, and that Lambda could be triggered from your workflow or as like an API endpoint that you call. Or your workflow, you could have it instead, if you don't want to translate it after every commit, you could have it translate once an hour or every 20 commits if you add in another scheduler of some kind. So it makes it portable in a way that you can integrate or deploy it in several modes. Okay, so another example, right? Snowflake has the Iceberg external tables. And so let's look at a flow of, if Snowflake writes an external table as Iceberg, can I read it from Databricks with Delta Lake, right? So in Snowflake, if I come here, you can configure an external volume, and this will write it to S3 itself. The external volume I already configured before running this demo here. And so I'm specifying that external volume. I'm using the Snowflake catalog, and this base location is basically the folder path inside that external volume. So the external volume is this same S3 bucket. If I come back up here, I have configured it as Snowflake external. That's my external volume on S3. Okay, so I can create a table, and then I can insert data from, I inserted data from this TPCH data set that's already preloaded inside Snowflake. Okay, so that data is here, it is available, and I have it inside S3. And this is an Iceberg table, right? So here's my manifest files, and here are the Parquet files for that data. So if I come back to my notebook, of course I can query this data as Iceberg. And one thing to note as well, I mentioned that this is using a Snowflake catalog. One thing that I find interesting is something that I feel the data community is maybe not talking about just yet, but I think it's coming, is the catalog the new vendor lock-in? Now that data has been freed from vendors in open formats and has been spread around, I see vendors scrambling right now to extend their reach and build this new lock-in with catalogs. So take this example right here from the Snowflake documentation. If you don't use their catalog, you don't have write support, and you don't have full platform support, which is like a whole collection of features and capabilities inside this thing. So you're tied to Snowflake still with the Iceberg external tables with their catalog. Anyways, now that it's written as Iceberg, I can execute the same metadata translation. So let me come here, and I have it just without the 0. I'll run that. I specified that my source format is Iceberg. Sorry, I don't need the markdown file. I specified that my source format is Iceberg, my target format I want Delta Lake, and I passed it that same path. I execute that, and the synchronization will complete. I see some chuggles, you like the memes on here. Let me show you that in S3. Okay, as it loads, it actually, because Iceberg has this, it has data and metadata in separate folders, it will put the Delta Lake transaction log or the Hudi timeline inside the data folder directly here. So you see the Delta Lake transaction log is there, synchronization complete, and now I can read that same table that Snowflake wrote out as a Delta Lake table. So I think this is pretty exciting, what this can unlock and the scenarios you can achieve with it. With this, I think we still have time as well. Let me check my here. Yep. Okay, with this, I want to show you one more type of an example, okay, with OneHouse specifically. So, and this example, we're going to use OneHouse to do a change data capture flow to replicate data from Postgres and ingest that in near real time. Under the hood, OneHouse is standing up and operating for me Debezium, Apache Kafka, and it's operationalizing Apache Spark clusters to run that ingestion operation. It interprets the WAL logs from Postgres, and it will materialize and apply the merge statements to those logs so that I have a full change data capture table. It's going to write it in. I'll show you how we can write it as Hudi, Delta, and Iceberg, leveraging Xtable, and then you can plug it into any query engine at the top. Okay, so let me flip. I think it's on, it's just in, I just put it in Chrome here. Okay, so this is OneHouse that you see here. When you first log into OneHouse, you'll see some helpful tutorials and how to get started. I have an environment already set up, so I will switch there. And the first thing I would do if I want to create this flow that I just described, I would come in to add a new data source. And you can see there's various options in here. I can say, hey, I've got data up in Postgres. So I can plug in my credential details or reference it in a secret manager native to the cloud if I didn't want to pass the details here. After the source is created, I can create a pipeline. So I can come and say, let's ingest this data from Postgres and specify that source that I had. If I want to apply the mutable updates and deletes, I can do that. I can also just write every transaction raw as itself and materialize it later if I wanted to. I can choose the tables that were discovered inside that database, and I can apply advanced features like data pipeline quarantines, or I can apply some, like for example, some data masking or some low-code transformations to perhaps filter some values. Maybe there's some row condition that I want to filter out from the schema here, or I want to unnest a nested JSON object or something like this. I choose some primary keys, partition keys, these kind of things, and I'm off and running. Now I can synchronize this to multiple catalogs simultaneously. This is all writing into the S3 bucket inside my environment. So on the catalogs, like you have a choice to do like multiple simultaneously, which some people are like, oh, well, do I have to choose just one, right? Some people have Glue and Data Hub. Some people are also in an HMS and they want to still use the Snowflake catalogs that are built in there as well. So I can have that set up. OneTable or Xtable, I still have to change the name inside the product here after we just recently renamed it to Xtable. But here you see it's a checkbox level exercise to have this data written as Hudi, Delta Lake, and Iceberg all simultaneously. And then I can synchronize it directly to Snowflake and provide the details to which warehouse and catalog I would like it to sync there. So as that's running, you can monitor the pipelines. Here's an example of a pipeline that's running, and it's streaming data in near real time. I can look at logs and the setup of these, and I can now see, perhaps if I wanted to browse that data, let's look at one of the tables. I can come and look at the table, see a little bit of details of the schema or how it's being written, how the table is growing over time. I can customize advanced tuning if I want to apply some like Z-order clustering based off of this category code per se. And I want to run that every 4 commits, or I can customize settings on that. Anyway, so this is all running. We deploy all these services inside your environment, inside your private networks, your VPCs. So none of the data ever leaves your account or that we have access to. All of it writes to your S3 buckets. And so this is where it's writing down here, Acme Retail Data. And I have all of the folders and things there. It's also synchronizing to my AWS Glue catalog. And so if I cracked open Athena or if I cracked open any of the AWS native tools, I would see all of those tables just there and available to query. They're all ready to go. Now I can also open up Databricks. And because I've written this data as Apache Hudi, Apache Iceberg, and Delta Lake, I can have this synchronized to the Databricks Unity catalog, and I can benefit from all of the great features that Databricks has built in. So I'm reading the same data with .format Delta, and I can do some advanced like data science or data modeling. I think I saw even on Twitter today, Databricks had an amazing announcement of some new model that they just released as well. So it was interesting with the panel discussion. Maybe I hope they get that model in the arena that DJ and the other professor was describing. So yeah, hopefully you can see from this quick demo how easy it is to use Apache Iceberg and get started. So come check it out on GitHub. Check out the documentation, and I'd love to take questions on it as well. If we could switch back to the slides, I have just maybe a couple of things to go through to conclude. So Apache Iceberg, the vision for the future, in goals, we want to eliminate data silos. We don't need to have data format wars. We don't need to have long and arduous processes of trying to benchmark and compare and test. Just know that and have that comfort that you can use all three, and if you had picked one, it's like seamless and very fast to switch back to another and go in between. I had someone ask me a question, oh, can I do a migration now with this, a migration from one to the other? No, well, that word migration is actually a funny word because it doesn't even have to like feel like a migration. When you hear the word migration, this is usually some like multi-month long, like huge investment to go migrate something. No, you like run one thing, it translates the metadata, and all of a sudden all of your data from one format is the other format. And it doesn't really matter. This was donated to the Apache Software Foundation because the ASF has an amazing track record of projects that probably all of you use and love out there in the community. And a project like this needs to be neutral, and it needs to be open. And there are committers and contributors from all three of these communities, Delta Lake, Hudi, and Iceberg, now participating with Xtable as well. And we want to foster and grow that open source community that way. So initial committers include this list from folks like OneHouse, Microsoft, Google, Cloudera, Adobe, Dremio, Walmart, and it's growing by the day. There's an exciting roadmap, initial roadmap for Xtable. The roadmap needs to be defined by the community. Since this is the very early stages, like let's blow this roadmap up. Let's change it into what do you see, what do you need when it comes to interoperability between these table formats. Of course, let's build this together. This is a community effort. Come find it on GitHub, find the docs. There's some social handles. And you can subscribe to a mailing list. This is common with all the Apache software projects. That's where most of the discussions will get done. That's where most of the coordination will get done. So join that mailing list and follow along or chime in with thoughts, ideas, discussions there as well. With that, at OneHouse, if you have been using one of these projects, if you are struggling with or interested in accelerating your lakehouse, there's multiple ways that you can engage with OneHouse. We have the ability to run some very lightweight monitoring services to give you insights on how to tune your pipelines. We have ways to tune those pipelines for you on the side, or we can run that full managed ingestion services and capabilities like I showed you in that demo as well. So with that, I want to thank everyone for coming.